Hello guys, how are you? So on today's video, I am going to discuss about the sieve algorithm. So how we are calculating prime numbers in any numbers in any numbers in range of any numbers. How we are calculating the prime numbers for the range from 1 to n. So for going for time factorizations for sieve algorithms, what we are going to do. So this is can be done by using sieve algorithm. So sieve algorithm says just like you want to calculate the prime numbers between for number 30, or in range of 30 how many prime numbers are present. So how we can do, I just say from 30 just print that number and mark all the number is a prime number first. First mark for the prime number is 2, just like 6, and it is like 7, 8 to 30. I says mark all the prime numbers to be true. 12 to 30. And what I says, at first every single numbers are the prime number. And I says grab the first prime number 0, 1 and 0 and 1 is already a prime number. So we start from 2 and I says every multiples of that number marks every multiples of that number to be prime number false. Make the every numbers of that multiples of the numbers to be false. Means I says now the multiples of first prime number would be false. Now 4, 6 and 8 and 10 and all of 2 of multiple will be become false, and 2 is counted as a first prime number. So we will do again for next prime number 3. We select this prime number and marks all the multiples of that prime numbers to be false. So actually what happening, you are understanding that their multiples are should be not be a prime number, so we are marking it as false. And we do for same 5 number, so we are counting as 5 becomes true, so it is counted as prime number, and all of these others are remain as it is. So by this method we are able to finding the prime factorization method. So if we talk about the coding sector, so I can say first I take a long number just like US says 30. For calculating any number, I just take a long number, take one is 7, and what I do, first I mark the prime number as false. So first we are marking all the prime numbers to be true, and when the multiples are found, we are marked as it is as false. So at first this could be in vector boolean form, vector boolean, and integer. Okay, so what is the array? I say just like this kind. Is prime to be what? Okay, where it is what is happening here? I don't know what is happening. So So first 0 and 1 is already prime, so you can say mark my 0 and 1 is already prime and equal to false. Now it should be in increment function. So what is the error? So after marking 1 and 0 is false, we come on to our second number, and for second number we need to mark their multiples to be a false. Mark their multiples to be false because uh, if the multiples are present in the array, then they must not be prime, because a prime number is a number that is only divisible by 1 and the current number. So I just move for int I equal to 2 for I less than n, and from I equal to 2 to the move from the I equal to n, I make this prime to be the false. Okay, this prime to be is prime to be I to be true, to be true. In this time it is counted, so it should be a true. And after this we again need to calculate for from 2, we are marking all the false, and for so j for calculating, so our inverted j, so j is for deleting all the multiples. In this time it is counted as to be true, but their multiples will not be uh, converted into false, so we need to start from j equal to I, and j is less than or equal to n, and j plus plus j plus equal, you can see he is shifted to for I, for just like it is 2, then there will be gap of I which is 4, then there will be again gap of I which is 6, then there will be a gap of I which is 2, then it comes to 2. So j plus becomes equal to I, and equal to n is goes for the n numbers. And for integer j, what is check? It's make I, this make your now it's marked as true. Now equal to j equal to false. Now it's marked as a false. And after all of this, what I say today, return out all of my prime. So it is like now he is marking as prime, and if you want to check the result, you can say for int I equal to 0, I less than just I want for 100 number, just like I want to check for the number 100. So what I do here is I just Pass is prime and I. Okay, I just check for I. So I did a little mistake here. It is only for j, so we need to remove the j and make it as now is prime j equal to false. It looks good. And after this, if you want to check the result, I just say please show me the result. Okay, so this time we are not in a directory. Just we need to go for the directory. So now we are coming to the directory. Now we can run it. Okay, if you talk about the time complexity, so you can see the number is divided by 1 by 2 in each times. For every prime numbers it is divided into 1 by 2. Selected for 2 it is divided into 1 by 2, and for 3 it is also divided into 1 by 2, 1 by 3, and for every numbers it is divided into, and at the end is divided into 1 by n. So it comes to as n log n. Each number is divided by 1 by 2. Okay, so you can see the results are coming here, and all the results are marked as 1 and 0. 1 represent for the number is a prime number, and 0 represents for the number is 1, not prime number. Okay, so from this, if we talk about the count time complexity, as you can see, each number are divided by into half, so their time complexity will become log n. So there are n prime numbers could be, so n into log n, and each prime numbers are again divided by into 2, so its log n is again converted into log n, so their time complexity becomes n into log n log n, n into log n into log n. So if we talk about if you want to print as a numbers form, means you want to see which number have a prime number, so what you're gonna do is just take a num and take the number as input. Just take a range and take as input, and what we will do is for a particular range I say equal to 0, I less than n, and I plus plus. I just call the function at the time. What is the function? My is prime. This is prime to be I, and let's see what the result will be. No, the result should be 1, so we need to say if is prime to be true, or 1 is prime I to be 1, then print as print as what print as two prime number. Okay, print as of prime numbers, as in the field print as non okay. Let's see it will run or not. Yeah, I think it should be run. So the time complexity will be In this time, what will be is this time complexity league of log and log. So guys, you can check if I say I want to check for it's like it is running in this time. Just wait. I says I want to check for 7 number. I've just put 7 queries. So I check for first queries. It is non-prime. White is non-prime. First is not. Okay, it is false. Okay, first is non-prime. Okay, if we check for 5, then you can say it is 5. You can check for 91. It is also prime. 77. It is prime. Oh, 77 is a prime number. Yes, it could be a prime number. House in this one is a final, yes, it's final. 33 it is fine for 88, not fine. Okay, so you can see the results as you on the screen. So that's for today, guys. We will back again.